So let's start then. I will share my screen. Can anyone tell me if my slide is visible?
Yes.
Yes, slide is visible.
Okay, so let's start. Good afternoon, one and all. Myself Yashvi, PhD scholar at IIT Bombay, and this is the second live session for the course Basic Environmental Engineering, Pollution and Abatement. And so far we had discussed in the first week what all is included in the environment, what is ecosystem, what kind of pollution exists, and what are the major reasons behind the pollution and all. So now moving forward for this week, in the last week there was a question which was not solved, and like as per the rules that I know, like I got to know. So the assignments that are given to you, that you have to solve by your own, uh, and you have to upload that. So later, once you have uploaded, I can help you out if you are not able to solve. So since you have, I guess, already uploaded week 1 assignment, so we can solve this question. So can you just try? Can anyone tell me the steps? How can we solve? I have already written the formula. So firstly, read the question and list down what all data has been given to you, and based on that you need to use this two formula, and you need to calculate the answer. So anyone, have you calculated?
KOW value is given as 110.
Yeah. So this is
So from
given
that
as
we have to first calculate log BCF by using that
correct.
value.
Correct. So log BCF is equals to into
0.79
log
into
of
log
110
110
minus
minus
0.4.
0.4.
I guess there was
Yeah.
some query in mathematical calculation also, like how do we need to do. So log means, I had already mentioned, this is log to the base 10. So calculate log to the base 10 of 110.
2.041.
Yeah, so log 110 is 2.04, and you
1.
yeah, so 2.04 is okay,
Yeah.
and you multiply it with 0.79.
0.7.
So I will just write down so that it becomes helpful. 2.04
1.61.
minus 0.4, so into 0.79 is 1.61
61.
minus 0.4. So
Yeah.
this will come out
1.21.
to be 1.213.
1.21.
Yeah, this 3 you can omit. Now this is log BCF, so which means to calculate BCF you need to take anti-logarithm to both,
Anti-log of.
on both the sides. Okay, so since this is log to the base 10, you have to take anti-log to the base, like so, which means you will get BCF, and here you need to have 10 to the power 1.21. Okay, so calculate that.
16.32.
16 point. For me it is
32.
coming as 2, so let it be, like it can be anything. Majorly 16 is the initial one, so that's okay. Now for to find out the concentration in the animal, we need to use this formula. Now what data you have given is BCF we have calculated, and the concentration in the environment that is existing
Point 5.
we know. So here the environment is given as lake water. Okay, so concentration in water is given as 0.5 milligram per liter. Now you just simply need to put up, like this will have unit. Okay, so you just simply need to put up the values. C in organism, okay, divided by C in water. If you put up the value, C in organism will be 16.2 into 0.5, which will approximately come out to be 8.16 milligram
0.6.
per kg. I hope everyone is able to follow this. Yeah.
Yeah.
Okay, so if you have any doubt so far in this question, like if you had doubt, otherwise I will move forward. Okay, so since if you don't have any doubt, then let's move forward. So now we will start with the brief of the lectures covered in the week 2. So starting with the lecture number 6, basics of environment and what kind of um, uh, things which we do results into the disruption or quality degradation of the environment or ecosystem. That all we have studied in so far. So what is pollution? So pollution is nothing but introduction of harmful or contaminated materials or contaminants into natural environment by any means. It can be natural means also, or it can be man-made or like due to human intervention also, that will lead to the adverse or harmful impacts on the natural environment, or we can say the qualities of the natural environment, it will degrade. Okay, so it can be any chemical substance, or it can be in the form of noise, like energy in the form of noise, heat also. So as I mentioned, it can be of it, the pollution in natural environment can occur due to following, like it can occur due to natural circumstances, or it can be due to human intervention. Now if you consider natural things, then volcanic eruption, forest fires, these all come into natural ways, due to which the pollution can occur. So can anyone tell me what type of pollution can occur if you have volcanic eruption or forest fire?
Air pollution.
So yeah, air pollution can occur because it will have a lot of gases or soot formed, because there will be fire in, like there will be fire of the trees, entire forest will be under fire, so there will be some soot formation, there will be gases formation like CO2, some sulfur or nitrogen oxides also. And similarly in volcanic eruptions, there will be similar air pollution, or now there will be lava also, there will be here heat generated here also, so nearby there will be some change in the temperature also. This is how heat or the temperature change is also a kind of pollution. This is how it will appear. Now all this kind of pollution that are like very rare, and since like nature has that ability to minimize the pollution on its own up to certain level, like this terminology we have discussed, which is nothing but like what stress it can handle. Okay, so like mainly if natural circumstances occur, then that can be taken care of naturally itself. Now otherwise, if we have main human intervention and we have man-made sort of pollution, then it can be due to domestic or like due to some household usage, due to some commercial activities, like we travel from one place to another through any vehicle or any such thing, like if we have a public transport, train, flights, and so on, and obviously the industries. So all this come into picture of human intervention. Now depending on the phase of pollutant, it can be of gas, it can be of liquid, and it can be of solid. Now solid and liquid, they both are interrelated, like actually all are interrelated, but majorly solid and liquid are interrelated. So firstly, if we take example of gas, then major pollutant can be carbon dioxide, carbon monoxide, SOx, NOx, then pan. Nowadays uh, like this was discussed in the lecture also. So can somebody tell me the gaseous pollutant which is it like which used to be emitted to the atmosphere, and it is like used, like it was earlier used in refrigerators? Anyone?
CFCs.
Yeah, so CFCs are the example of like it is a refrigerant, and it is emitted in the atmosphere, and it is also a pollutant. Okay, so we will further see how it like what, why is it a pollutant? Because it depletes, like it reacts with the ozone layer found naturally, and it depletes that. So these all are some of the examples for gaseous pollutant. Now liquid pollution, like liquid pollution majorly revolves around water pollution, because earth, if we see, then majority of portion covered on earth is water. Okay, so nine, like soil. So water pollution can occur in the form of, like there are natural pollutants also, like if we say arsenic is present in groundwater naturally also, fluorine is also naturally occurring. Now these two are natural pollutants. However, further organic, some organics from pharmaceutical industries, from textile industries, and so on, they can be emitted in the water bodies. Then heavy metal, then some suspended solids. Now even plastics are, we just dump in the water bodies. So such pollutants are like maybe in liquid form or maybe in gas solid form, they can add on to the water pollution. uh, can you give few more examples of water pollution, like what have you seen? Like you can consider pollution as the yeah, nitrogen and phosphorus concentration that are increasing or changing in the water bodies. Yes. Then the dissolved oxygen concentration, which is required for the existence of aquatic living organisms, if it changes, then also, like if it departs from the natural DO concentration, which usually should be, then also it is a kind of pollution. Okay, so change in DO concentration, change in nitrogen and phosphorus concentration, these all are also considered as water pollution. Now coming to the solid or soil pollution. So mainly soil pollution, so this a majority portion comes as what we call as landfills, like from the landfill sites, because what solid waste are generated in our houses or in industries, those all solid waste, they are at the end discarded or just dumped into landfill sites. Okay, they like say for example, this is the layer of soil on earth. They dig out some soil, they start dumping the solid waste in it, and they again cover it up with the soil, so that further it can be used for some purpose. Now what happens is, if you have dumped all the solid waste here, then so like as you know, soil is porous. Okay, so uh, on coming with water body or on rain, water will percolate, and some of the solid has tendency, like it will dissolve with water and it will again percolate back in the soil. So this is how it is known as leachate. Okay, so this leachate will go again back, like through water it will again pollute more soil. So this is how soil pollution occurs. So this is all about types of pollution. Now moving forward, it can like pollution can have mainly point source or non-point source. So for point source, if like it is just say for example, if we have one industry and it is emitting one wastewater stream, so we know from where it is coming. So in that case, like for the source of pollution, if we know from where it is coming, if we are able to find out its location, then it is a point source. Like it has not been discarded, so that we can avoid such pollution. Like further pollution or further mixing of various streams so that it spreads, it can be avoided. Now coming to non sorry, non point sources, like if we have some spill and we do not know, like if we have a spill in river, and this river body comes in contact with another stream, then we do not know where exactly there was it start, like where it started. So we will not be able to find out its exact location, so that we can have treatment, or we can uh, change, or we can stop the further pollution. So in that case it is non point source. Now impact of pollution can be reduced through these phenomena. Like these all are natural phenomena. Say for example, if just a second. Say for example, you have a river. Okay, now here you are, this is the point where you are dumping one more waste, like one wastewater stream which is highly contaminated with various pollutants. Okay, so now it will get added here at time t equals to 0. Now as water, like as you know, water bodies are always flowing, and also here as you add, the concentration here will be C max. So here, like if you consider these two regions, then there will be some concentration here maximum, and here the concentration is not there. So there is concentration difference also, and also there is bulk motion of water. So you can say that there will be two types of motion of pollutant due to diffusion, which is occurring because of concentration gradient of pollutant, and also because of bulk motion of water. So in this case you can say that the pollutant is. Madam, it's not great. Can you please mute yourself? Huh? Yeah. I'm not getting you. Can you please write in the chat box what you want to say? You are not clearly audible. Okay, so let me go ahead. So in this case you can say, as it moves forward, it disperses in this water stream. Now this you can say for air pollution also, like if if this is the chimney and you are just emitting all the gases from this chimney, then it will like due to diffusion and bulk motion, it will diffuse in the air, so that its concentration, if like here it will be high, but as you move forward it will get reduced. So this is a kind of phenomena which is known as dispersion. And like if we see, then over the period of time the concentration will reduce. Now next phenomena is known as dilution. So dilution is nothing but, if you have, say for example, one concentration C1 as 10 ppm, like ppm as you all know, it is parts per million, and this is the most commonly used concentration. Now if you, by any means, if you have more solvent or more mixing, say for example, if you are adding a wastewater stream here with very high concentration, if it gets mixed with the bulk river water, then what happens is, at the end, like if in the bulk the C1 which was in the wastewater stream 10 ppm, it will get reduced to, say for example, 1 ppm. So this is a kind of dilution. So dilution is also a factor which reduces the impact of pollutant, because obviously less concentration is observed, but it will be available in more region. Next is deposition. Now for deposition you can say that if you like have solid in water or solid in air, then due to density difference or maybe solubility difference, then it will tend to settle down or it will tend to precipitate. In that case it is known as deposition. So it will no longer be available to living organisms, so that it has adverse impacts. Now another is degradation. So degradation is nothing but, say for example, if you have A, B, C as a molecule, then there will be some reaction that will occur which will result into formation of maybe AB plus C, or maybe AC plus B, or maybe A plus B plus C. I am just giving a random example. So these are all degraded or decomposed products. So maybe this all individual components will have lower ability to have, or it will, the hazardous impacts will be less. So this is nothing but degradation. So now moving forward, another terminology that, like, so far we have covered in brief. So again there in detail water pollution was covered, which means the characteristics of water is changed by addition of contaminants in the water bodies. Now it can be because of excess of physical, chemical, biological substances. Okay, so physical substance can be like if water is in liquid phase, then physical will be all the contaminants in some different phase. Say for example, suspended solids. Now chemical chemical pollutants can be all which is like all sorts of salts, then nitrogen, phosphorus, etc. And biological can be microorganisms, or there is one more thing which is known as BOD and COD. Like obviously these are the organic compounds, but what you can say is these all can be degraded by the presence of microorganisms, like especially BOD, and COD can be degraded by the addition of some chemical compound. So all these are the kind of pollutants which can be present if we bifurcate in terms of physical, chemical and biological substance. Now as I mentioned, the contribution can be from uh, rain leachate, as I have shown here. If you have some solid decompose like dumped here, then if there is rain and it goes through that dump yard, and it tries to dissolve few solids which will be a leachate, and it will again percolate, and it, like if more and more comes, then it will get and it will end up in some water body. Then there can be some oil spills. Then there can be some domestic pollution in the form of like some wastewater from toilets, wastewater that can be generated if you have some, like if you wash clothes, then there will be some wastewater generated, so laundry. Then there will be some wastewater which, like for example, if you are washing the vegetables and fruits, then like nowadays pesticides and insecticides are used on vegetables. So if you wash it, and that water is obviously just discarded into the sink, okay, so that will lead to the addition of pesticides, insecticides, etc. And obviously the industrial wastewater, that will have a lot of pollutants added manually. Now coming to air pollution, it is nothing but the abnormal amount of chemical constituents in air in the form of particulate matter, gases, etc. I have already discussed about gases. Now particulate matter, the lecture, like sir has shown various harmful hazards which can occur, like it can be divided into PM10, PM2.5. this is based on the size of particulate matter. Now if it is much bigger, say for example if it is PM10, then it can be inhaled, but it can be blocked by nose, because somewhat it is bigger. Now PM 2.5, it can penetrate into, like it can go to till our lungs. So depending on size, it can enter our body, and it will, like if more and more are taken, then it will damage our lungs. It can cause bronchitis, it can cause asthma, etc. And soil pollution is also discussed, like as I said, some solid is dumped, which results into soil pollution. Now based on what amount of pollution is generated from industry, because if you take into consideration human intervention for pollution generation, then industry is a major source. So based on what amount of pollution can be created in the form of water pollution, air pollution or soil pollution, it can be divided in red, orange and green. So red are considered to be one of the most polluting industries, orange is considered in between, and green is considered the one which creates please mute yourself. So green are considered the ones which has least pollutants. So there are certain criterias, and you can check on CPCB website also if you want to get more details. So one of the example of red, like the most polluting industry is pulp and paper industry, which emits or which generates a lot of wastewater. So now moving forward to lecture 7. uh, what all are the impact of water pollution. So as I have mentioned, it can be due to physical, chemical, biochemical, which I have mentioned as BOD, COD. Chemicals are all sorts of salts, nitrogen, phosphorus, and physical can be suspended solids or any sort of material which creates some visual changes in its quality. What is it? Can you please mute yourself?
Yes, ma'am.
Why is someone creating so much disturbance?
Yeah. Actually, I want to ask her a question.
Yeah.
Actually, ये जो ये जो सस्पेंडेड मटेरियल आपने बोला ना अभी,
Hmm.
अच्छा ये वोलाटाइल सस्पेंडेड मटेरियल,
Hmm.
ये वोलाटाइल सस्पेंडेड मटेरियल के फिजिकल कैरेक्टरिस्टिक्स में आएगा?
Uh, See, if the suspended material is present in water, then there can be some volatile organics also. Okay, it can be in liquid state, but if it is in solid form, then like there will be some visual changes in water due to that. And over the period of time, yeah, there can be like, as you know, there can be equilibrium, like not all can be evaporated, or depending on its characteristic it will evaporate. So yeah, it can come actually. Okay, so microbiological pollutants can be in the form of microbes, and this all can be bacteria, virus, which results into some adverse health impact. um, can you so now, like, moving forward, as I said, DO depletion or change in the DO concentration in water bodies is also one of the kind of impact of water pollution. Can somebody tell me how DO depletes and what is the mechanism for it, like it is discussed in class?
Due to the growth of microorganisms on the surface of water, the oxygen transfer gets reduces, and because of that, the oxygen level below the water reduces.
Mm, Actually, I could not get you. But say for example, there will be some organic contaminants in water. I will just clarify what you said. Like, I guess it is partially correct. Say for example, you have a water stream in which there will be some organics. Now this organic will be in the form of CXHY, maybe oxygen, or maybe some sulfur, and so on, like it can be AB. So if microbes act on it, microbes usually will be some bacteria. Now if this acts upon this, then by using some oxygen which is there in water already present, or it can use some oxygen from atmosphere, and it will result into some decomposition of these like this the organic component. So this is how it will take up the oxygen. So this will result into the change or decrease in the oxygen concentration which is present in water bodies. So if the organic contaminant as increases in water bodies, then obviously there will be decrease in dissolved oxygen concentration, and it will adversely affect the living organisms present in it. Okay, now moving forward, there can be some arsenic contamination, there can be fluoride contamination, etc. And like due to this there can be cancer, there can be damage to various organs, there can be damage to brain. For fluoride, it can be fluorosis, which can be some defect in bones, also some dental uh, health change also can be observed. Now moving forward, air pollution impacts. So it depends on particulate matter. As I have mentioned, it can be of particulate matter can be of different sizes, PM10, PM2.5, and depending on the size, it will reach our body and it will result into bronchitis. It can result into asthma. Now there can be carbon monoxide also. So somebody can tell me, like, from where carbon monoxide arises and what are the adverse health impact on human due to carbon monoxide.
Carbon monoxide arises due to combustion of fuel.
Yeah, it actually arises because of partial combustion, because if it is complete combustion, then it has to be CO2. Okay.
Yes,
So
yes.
yeah, carbon monoxide, it will arise from, like, if you are using fuel in vehicle and there is some partial combustion, then there will be partial combustion of fuel. It will result into carbon monoxide formation. Now carbon monoxide, if we inhale, then it has the tendency to bind with hemoglobin to form carboxy hemoglobin, okay, which is a compound which reduces the oxygen concentration in our blood, okay, because hemoglobin is responsible to take up oxygen from, like, that we inhale. So this results into adverse impact on human being. Now
Madam, carbon monoxide.
yeah,
Madam, carbon monoxide also comes from the thermal power plant flue gases, like fly ashes.
yeah, it will come definitely, like wherever
Yes.
there is some, like I just gave example for vehicles, like this is just one example. All sort of fuel where it is combusted, if it is partial combustion, then it will result into CO generation.
Yes, ma'am.
Yeah. So yeah, then there can be SOx, then can be NOx. So say for example, NOx, it will use up the oxygen to further oxidize, like it will, if it is NO, then it will get converted again back to NO2, and it has further tendency to react with say for example ozone in the atmosphere. So the chain goes on. So these are the few examples of impacts due to air pollution. Now soil pollution impacts, uh, as I mentioned, it can be due to poor management and disposal of waste. There can be some waste from agriculture in the form of agricultural waste, crops, like crops, if it is there and it is disposed as it is, then there can be some excessive industrial activity. So all sort of solid, it will result into soil pollution. And the impact can be, for example, there is some pollutant which goes into soil, say for example if it is some metal, lead, okay, if it, like it is there in soil, now it will be taken up by plants and it will affect not only its growth. Now this plant will have lead to some extent in it now, and it will further move on to the next species, like in the form of, like through food chain, whenever thus this plant is consumed through food by human beings or by animals. So this is how it goes into the food chain, and it creates some hazardous impacts. Now coming to noise pollution. Noise pollution is like, as I meant, noise can be measured or the intensity of noise can be measured in decibel. This is the unit. Now if this there is some limit for noise that can be tolerated, okay. Now if it exceeds that, then there can be some annoyance, okay. So if, like, as you know, if someone is shouting just beside you, then it can annoy you, okay. Now if such exists due to like some industrial activity or some construction, then it can result into noise pollution, okay, because there will be a lot of sound. So there can be loss of hearing, there can be some change in human performance because it will constantly disturb you. There can be damage to material also because it will have like sound waves, as you know, it has a lot of energy. So if it continues, then there can be damage to material, and buildings can also collapse, um, or there can be some physiological effects like. So moving forward, another thing that was discussed was ozone layer depletion and global warming. So ozone layer depletion, as in the starting of class we had some discussion, like CFCs are one of the refrigerant used, and it is one of the pollutant which is emitted in the atmosphere, okay. Now this has the tendency to react with the uh, like for example, this is earth, then in the stratosphere there is a layer of ozone. Now this CFC from the surface of earth, it rises till this ozone layer, and here it reacts with ozone. Now why does this create some adverse impact? So can you tell me what is the role of ozone? Yeah, can you tell me what is the role of ozone, like how it is important?
It protects us from the ultraviolet rays coming from the sun.
Yeah, so it protects us from the ultra UV rays that comes from the sun, and it so UV rays do not reach us. And if this CFC reacts continuously with ozone, then what happens there, like as it is well known to all of you, there is ozone hole formed in the stratosphere. Now in that case, directly the UV rays will reach us, and it will be hazard, like harmful to us, because UV rays can cause cancer as well. Now another term was global warming. So as you if this is earth, then earth has its natural atmosphere, like naturally there will be CO2, CH4, and so on, and these are natural greenhouse gases. Now up to certain level it is already there, but if it is added by some human intervention through industries, or so on, then it will add to the concentration. Now this CO2 absorbs the infrared rays from the sun, like infrared rays coming on the surface of earth, and due to the absorption of those rays, there will be some warming, like it will not allow this rays to reflect back or go back out of the atmosphere. So due to that, there will be some warming on the earth. Now if this would not have happened, then earth could be very cold, like in some minus like minus 30-40 degrees Celsius, or so on. It can be that cold. So it helps in surviving of various living organisms on earth. Now as the concentration of CO2 and CH4 increases, and more greenhouse gases are emitted, then it will absorb more and more infrared radiations coming to earth, and that is how the average temperature on the earth, it will rise. This is nothing but global warming. So moving forward, let's go to lecture 8. So dispersion we have discussed, and air pollution dispersion is nothing but distribution of air pollutant in the atmosphere due to diffusion and advection, as I mentioned. Like diffusion is due to concentration gradient, and advection is the bulk motion. Due to both these phenomena, there will be transport of air pollutant from one place to another place. Okay, so advection, like, which is nothing but the bulk motion, it will depend on the strength of wind and its direction. Now coming to another terminology, which is nothing but air atmospheric stability. So it is the measure of air's tendency to resist vertical air motion. So Earth's atmosphere, if this is the surface, and if you move forward in the vertical direction, then what happens is, say for example, the usual trend is the temperature reduces. Okay, and if we have some air packets or air parcels, if the temperature of that parcel is like higher as compared to other atmosphere due to some reason, then higher temperature will have lesser density and it will tend to move upwards. So in that case, if T is higher than what it should be, then it will result into upward motion, and this is nothing but unstable situation. Now stable situation is when you have a cool packet, say for example some condensed or lower temperature it has, then it will tend to move downward due to higher density. So this is a stable situation. And when you do not have temperature gradient, then it will be in a neutral condition. So this are the terminologies for air stability. And the change, like say for example, as you move upward, the gradient in temperature that you observe is nothing but known as lapse rate, which is the rate at which air temperature changes with respect to height. So dt by dh is lapse rate. So till now we have discussed that pollutants, they disperse or they disperse in the atmosphere, and such dispersion can be modeled or they can be calculated. Say for example, this is the chimney at x equal to 0, and you need to find out at x equal to 3 kilometer what is the concentration of that pollutant, because anyhow it will go from this to this. So what is the concentration, it is whether it is acceptable or not, that can be found out through Gaussian plume model. So here there are certain assumptions made. For example, if this is the center line for like, you need to have coordinate system, and this is the center at which you are considering. It can be any like, this can be arbitrary also. So say for example, this is the center, then you Gaussian plume model assumes that this is a perfect Gaussian curve will be observed. So if you go plus, like in above or below that center, then the distribution will be uniform. Also the reaction of like contaminant which is present, it usually do not react with whatever it is present. And also the rate, the wind speed at which it is moving, it is constant with respect to time and with respect to distance. So based on these few assumptions, this equation has been derived for the calculation of concentration of any pollutant at a certain level away from the source from which it is generated. Now this is also important. For example, here this is the chimney from which you are emitting the pollutant, or it will have SOx, NOx and some carbon monoxide, dioxide. Okay, so to avoid or minimize the humans getting affected due to that, there will be, like, as you have already noticed, the chimneys are very tall. So why, based on what it is calculated? It is calculated depending on what concentration or what kind of wind speed is there in that region and how long it can travel. So based on that, some h or the stack height, it is calculated from which you should just dispose the air, like air containing pollutants. This was about air. Now moving forward for water, how it is there for water. So it firstly the terminology is aquifer. So aquifer is nothing but a body of rock or sediment that has some groundwater in it. Now if the subsurface is contaminated by any means, then there are chances that it further percolates through the soil. Okay, so here, to find out what will be further transport of the pollutant to from one place to another, a law is used which is known as Darcy's law. This helps in finding out, like it will predict how the flow of liquid occurs in any porous solid. So this is the Darcy velocity. So this k is constant. H2 and H1 are two levels at which we are measuring, and L is the distance, like the points at which we want to measure and how apart they are. So based on that we can calculate what kind of dispersion it can happen in the porous medium or soil. Next term was chemical retardation. So it is nothing but contaminant tends to react with porous media through adsorption and precipitation, which results into retarded movement. So for example, contaminant has some tendency to interact with what is present in that aquifer. That porous media is nothing but soil. So soil is also one of the natural adsorbent present, and it will absorb few organics or few microorganisms or so on. So based on that, due to adsorption, or there can be some solubility change inside the aquifer, which will result into the precipitation of that contaminant. And due to this, since there is a change in concentration, the retarded movement or a lower concentration further moves. So that the factor at which the motion gets retarded is nothing but total contaminant which is present in the aquifer per unit contaminant which is actually present in the groundwater. Next term what that was discussed in the class was the dissolved oxygen concentration. Now as I have mentioned that dissolved oxygen is used up to decompose all the organics by microorganisms in the presence of oxygen to form decomposed products. Now this decomposed product can be some complex molecule also, or it can be CO2 also. Now so it will take up the oxygen, and this organic which is present is known as, which can be consumed by microorganism, it is known as BOD. So it is nothing but a term used to check what amount of organic is present in terms of what oxygen will be required. So for example, 1 mole of organic will require, say for example, X moles of O2. So there will be a correlation between how much organic is present and what oxygen will be required for decomposition of that much of organics, and that is nothing but BOD. So since this will result into some consumption of oxygen in the water, there will be a deficit or there will be deoxygenation rate in the water body. Now again this water body is exposed to the atmosphere, which will continuously absorb the oxygen. So deoxygenation is the consumption of oxygen by the organics and there will be certain rate at which oxygen is again added back. So there will be some deficit or decrease in the DO created in that water body. So if the rate of deoxygenation is more, then there will be more and more deficit in the water body, and vice versa. So what you need is lesser and lesser BOD and more and more addition rate for that water body. So now we will move to the assignment or the model assignment for this week. So the first question is the man-made pollutant are produced through human activities. Identify the activity responsible for man-made pollutants. Find out the most suitable options.
All the above.
All
Yeah.
the above.
So these are some of the examples of all the activities. So for example, domestic activity include toilet waste, waste from kitchen, plastics, laundry waste, etc. Industrial waste, industrial activity will result into burning of fossil fuel, all type of chemical industry. This will result into man-made pollutants. Agricultural activities will result into pesticide, insecticide, some crop residue. So all of the above are the correct answer. Next is the process in which some substance breaks down by natural process into different and simpler substances is known as dash.
Degradation.
Yeah, so degradation is the correct answer, and here I have mentioned the definition of all of this. So this we have already discussed. Moving forward, next question is for landfill leachate, the typical range of COD for methanogenic phase is dash. This is given as some standard or thumb rule in the lecture. So can you please tell me?
500 to 4500.
Yeah, that is the correct answer. So can you tell me what is the meaning of COD, or can you differentiate between COD and BOD?
BOD is biological oxygen demand.
Hmm.
And COD, I guess, chemical oxygen demand.
Yeah, you are very correct. So BOD is biological oxygen demand. So as I have mentioned, there will be organics present in water. So to decompose that organic, if it is biodegradable, then it can be decomposed by some activity of microorganism. So and that microbes will consume some amount of oxygen. So depending on the concentration of organics present, there will be some amount of oxygen required by the microbes to decompose that, and that is nothing but BOD. Now not all organic compound which is present is degradable by microbes, and so we require some oxidizing agent or some chemicals to degrade that, which is nothing but chemical oxygen demand. So to decompose a given quantity of organic, you require certain oxygen, which is nothing but chemical oxygen demand, to decompose or degrade the organics present in water. Moving forward, find out the most suitable option from the following to explain the consequences of long-term consumption of fluoride contaminated groundwater.
Skeletal fluorosis.
Yeah, so skeletal fluorosis, because it affects the bones of our body, and it becomes weak as we take more and more of fluoride. So skeletal fluorosis is the correct answer. Next question is, which of the following option appropriately connects the transmission mechanism with examples of disease? So
The last one.
yeah, correct answer is the last. So here waterborne disease are nothing but due to the consumption of contaminated water, which is cholera, typhoid, etc. Water washed is caused due to lack of personal hygiene, and that is nothing but this dysentery, trachoma. Water based, so in this you do not need to consume such contaminated water, but there can be some microbe activity, or there can be some insects, or some organisms which will indirectly contact you with that contaminated water, and that is nothing but option number 2, like this. And water related, so it requires a medium, so you need to sorry, I just said the reverse one. So for this you do for this water related, you do not need any contact. So for example, malaria or dengue, then the dengue mosquitoes causing dengue, they will sit on the water contaminated water which is contaminated, and if it bites, then it can cause dengue. So here you do not need water contact, and here you need water contact. Next question is, a stable atmosphere will suppress or resist what type of motion?
Vertical motion.
Yeah, so stable atmosphere we have discussed, and stable atmosphere is required so that it will not have vertical motion. Now what are the reasons that can cause vertical motion of air? One of the reason is temperature. Yeah, so temperature gradient will result into vertical motion. For example, if temperature of a particular air parcel is higher as compared to the bulk air, then it will result into upward motion due to lower density. If it is lower, then it will cause sinking or downward movement of that air parcel, and if it is equal, then it will remain there only. Next question is, what is the assumption of the point source Gaussian plume model? So please read and tell me. If not, I will tell you. So first option is variable wind speed. So if you look at the equation, then you will see that there is just one terminology, which means that you are assuming wind speed to be constant. Okay, also there is a constant emission rate, because it simplifies the derivation of a particular equation. And also, like, so this is not correct, this is not correct. And also pollutant is conservative, which means there is no reaction, because if it reacts, then there will be one more terminology that needs to be taken care of for the reaction. Now you do not know whether the reaction it results into some some compound which is less hazardous, or it may be more hazardous also. So you do not know that, like, what will be the end product. So always, to simplify, we at start we assumed that the pollution, like the pollutant, is conservative. So here this is the correct answer, like these two are wrong. Next question is, find out the most suitable option from the following to identify the gases responsible for global warming. So all of the above is the correct answer. Yeah, all the gases are global warming, generating global warming. Next question is, a phosphorus limited lake with surface area equal to 80 into 10 to the power 6 meter square is fed by 28 meter cube per second stream that has phosphorus concentration of 0.01 milligram per liter. Now in addition, effluent from a point source adds 0.9 gram per second of phosphorus to it, and the phosphorus settling rate is estimated as 10 meter per year. Now estimate the average total phosphorus concentration. Can you are you able to understand the question? Okay, let me explain. So say for example, this is the lake already present, and it has surface area A as 80 into 10 to the power 6 meter square. Now it is fed with a stream of at a flow rate of a stream is added at a rate of 28 meter cube per second. So this is Q, which is nothing but flow rate. Okay, now and it has concentration C in as 0.01 milligram per liter. Now there is a point source which adds phosphorus to it at a rate of 0.9 gram per second, and phosphorus is accumulated, settling rate here means it is getting accumulated in the lake at a rate of 10 meter per year. Okay, so you need to find out what is the average concentration, since you are adding phosphorus externally through these two streams, what will be the change, or at equilibrium what will be the average concentration of phosphorus. So C final or C out. So here you need to make few assumptions. So what assumption do you need to make is, first one, it is at equilibrium. So what does that mean? Whatever is coming into the system, it will go out. So the flow rate coming out of this, it will be nothing but same, which is 28 meter cube per second. I hope you are able to understand. You can stop me if you have doubt. Okay, yeah. And second assumptions you need to make for simplification is that whatever concentration of phosphorus that is coming out, same is available in the lake. So you can say that there is perfect mixing inside the lake, so the whatever is there inside, same will come out. So concentration in lake and what is coming out is same. So let's say it is C out. So you need to find out C out in this case. Okay, so let's write material balance to do this calculation. Okay, so can anyone tell me what is the basic statement, or what is the basic material balance equation? How do you write any material balance? It can be for a reactor, or it can be for any system without reaction. Any material balance, a general material balance equation. Anyone?
Material flowing in is equal to material flowing out.
Yeah, so material in equals to material out. This is at equilibrium. Okay, so what if there is some accumulation term? So what you can say is material out minus in, plus if there is some generation, minus if there is some consumption, is equals to what is getting accumulated. Okay, so here what is the case, like this is the most general material balance equation, so which terminologies here will appear and which all will not appear? You can look into the schematics.
Generation section does not take place.
Yeah, generation and also consumption, because you are not like any reaction is not occurring. Okay, so you are adding in, like there will be in term, there will be out term also, and there will be accumulated term also. Okay, so for our case, what is going in is, like here it should be in minus out is what is getting accumulated, sorry. Yeah, because just to give an example, if you are giving in as 10 any unit, okay, then you are giving in, there is already something and you are taking out 8 only. Okay, so 2 will be consumed here, or sorry, not consumed, it will get accumulated here. So what is it, 10 minus 8, which is 2, which will get accumulated. So it has to be in minus out, that is accumulated. So now let's write material balance. So what is the amount of, so for here it is amount of P in minus amount of P out equals to accumulated. So P in here are through two streams, this one and this one. Now one thing that you need to take care is the unit should be same and unit should be consistent. Okay, so try to follow sorry, like if you get confused at any point, so try using SI unit, so that it will be easier for you. So in will be for two streams. First stream is Q in, like Q is same in and out, so Q into C in plus there is some effluent stream, so that E minus there will be some out, which will be Q into C out. Now why we are doing Q into C? Because Q is given to you as meter cube per second, like which is nothing but volumetric flow rate, and you are multiplying it with concentration, which will be in milligram per liter. So this is also volume, this is also volume. You need to obviously have unit conversion for unit consistency, but this volume will get cancelled out, and what will remain is milligram per second. This is nothing but mass or mass rate, because for material balance you need to have mass balance, not volume balance or concentration balance. Okay, so that is why we are multiplying Q into C. E already you are given as gram per second, so we do not need Q into C. And accumulation is obviously there will be some concentration. Okay, directly there will be not like here it is not flowing, because there will be a bulk mass. Now for that you need volume of water which is present in the lake. Can you tell me how we can find the volume of water which is present in the lake? There needs to be one term, volume, here.
Area we have given. From
Yeah.
area we can calculate the volume.
Yeah, so area into volume, like velocity, sorry, settling rate. So multiplying both this will give us mass rate again. So if we put up the values, Q we know, C in we know, this we know, C out we do not know, A we know, and settling rate also we know. Let me move to new slide. Yeah, so putting up the values, Q we are given as 28 meter cube per second, into C in is given as 0.01 milligram per liter, plus inlet of effluent is given as 0.9 gram per second, minus what is coming out is Q into meter cube per second. For avoiding confusion with unit, it is advisable to write units whenever you write this value, so you will avoid the confusion. Into C out we do not know, like we need to calculate that, and it is equal to C out into area is given as 18 to 10 to the power 6 meter square, into settling rate which is given as 10 meter per year. Yeah, 10 meter per year. So now since the unit are very like not matching and it is not consistent, we need to have unit conversion. So let's make meter cube to liter. Okay, so 28, or we can yeah, 28. So if we want to convert this, then 1000 liter will be equal to 1 meter cube. Yeah, so 1 meter cube will be 10 to the power 3, like this will be in liter again. Let's keep this to seconds. 0.01 milligram per liter. Now here it is in gram and here this is in milligram, so you need to make either conversion. So let's make this 2 milligram. 0.9 into 10 to the power 3, because gram to milligram is also like 1 gram will be 1000 milligrams. 10 to the power 3 milligram per second, minus 28 into 10 to the power 3 liter per second, into C out, because C out we need in milligrams, so it is advisable to keep mass in milligrams, and also we need per liter, so it will be better to keep volume in liter, is equal to C out. Okay, now this is 80 into 10 to the power 6 into 10. Now this whole will be meter cube. Okay, it will be meter cube per year. Now if 1 meter cube will be 10 raised to 3 liters, so this meter cube will be converted to liters, and you need to convert 1 year into second. Okay, so for that 1 year will have 365 days. Now this 1 day will have 24 hours, so 365 days into 24 hours will be total number of hours, and 1 hour will have 3600 seconds. So this is the conversion for 1 year into seconds. Okay, so let's put up all the values here and calculate C out. So first calculate this 28 in like 1000, you can calculate from divide from each, because it is there in each term. Yeah, so 1000 gets calculated. What remains is 28 into 0.01, 0.9 minus 28 C out equals to C out into 18 to 10 to the power 6 into 10 divided by 365 into 24 into 3600. Please calculate this to find out C out. Yeah, is everyone following with me?
Point 22 mg per liter, ma'am.
0.22? No. It should, like, there will be some change. You are missing some factor. It comes as 0.022. or am I making some mistake? Let me check. Can anybody else confirm? Yeah, so if I combine this two, then it comes out to be 1.18. Am I right? And this comes out to be 25.36, like this term. Please say no if you are not getting this value. So if I take this on right hand side, like this will be C out. So adding these two, it will give me 53.36 C out. So what remains is 53.36 C out is equals to 1.18, and if you divide, then 1.18 by this value will give me 0.022, and the unit here we have maintained as milligram per liter. Now is everybody following me?
Yes, ma'am.
Anyone if not getting? If not, we will move to next question. Find out the air to fuel ratio in mass to mass, which is required for complete combustion of a liquid fuel, which is having formula C7H13 in an internal combustion engine, and the reaction for the combustion is given to you. Okay, this is the reaction, and here you need to find out air to fuel ratio. So what do you mean by complete combustion? That entire fuel, it is converted to CO2. Okay, there is no reaction to form CO, so you need to follow this reaction. So here you can say the stoichiometric coefficient is 1. So 1 mole of this compound reacts with 10.25 moles of O2 to form give you complete combustion. Okay, now what is the stoichiometric ratio? Because you will not be giving pure air oxygen to the engine, you will be giving air to it. Okay, so what is the fraction of oxygen in pure air? Nitrogen here is inert, it will not get reacted.
21%.
Yeah, so air has 21% oxygen, okay, and 79% nitrogen. So yeah, so if we check whether these two, like oxygen to nitrogen, are in molar ratio or not, then we can just check 10.25. if we divide it by 0.21, then it comes out to be 48.81, and if we add this to 10.25 plus 38.07, then addition of both the moles, it comes out to be 48.33. so more or less it is same. So what is given to you is the moles of O2 air used. So moles of air required for complete combustion is nothing but 48.33 moles. Okay, and what we combust is 1 mole of the fuel. So here you need to find out mass of air per unit mass of fuel for complete combustion. Now what you know is moles. Okay, so you need to convert moles into mass by multiplying with molecular mass. So 48.33 you are given, and molecular weight of air is nothing but approximately 29. This is molecular weight of air, and moles of fuel is nothing but 1, and you need to multiply with molecular weight of fuel. What is it? Check the molecular weight of fuel. What are you getting?
$97.
Yeah, it is 97. Okay, so if you divide this, it will come out to be 14.4, which is very close to option number C, 14.37. Yeah, so do you have any doubt so far?
We actually have different question in our assignment.
Yeah, actually what I am showing you is the model assignment. The questions need not to be same.
But ma'am, it's we're not able to figure out the answer for that one.
Acha. Let me check that question. Okay.
I can send you the question in the chat
Yeah, you
box
can
if you want.
write on the chat box. Yeah.
I sent it now.
Yeah, C16H13.
Yeah, there can be some typo. Let me calculate the question in this manner. Okay. Let's calculate that.
I had calculated and got the answer in that, that is 14.28, but there was no option like 14.28. Near about there was option, but not exact the 14.28.
Acha. Uh, in that case, there will be some mistake in the question. So, what I am showing, like the method, if you have followed is the same, then you should get the correct answer. Is the method same which you have followed? What I have shown?
No.
Or else let me calculate. C6H13, is it right?
Yeah.
Okay. So it will give me 6 moles of CO2 plus H2O, and it will be 6.5. Okay, 13 by 2. So oxygen will be, here it is
9.25.
sorry,
In the left hand side it will be
12.
9.25.
Where are you seeing?
In the starting reaction, C6H13 plus 9.25 of oxygen.
Acha. No, it will not be 9.25 na. Wait just a second. 6 here it comes as 12 atoms of oxygen, and here it will be 6.5. So if you like add, then it will, like, these are the number of atoms. So
Yeah, for oxygen.
acha, 12 plus 6.5. Okay, so yeah, divide by 2. Yeah, 9.25. Sorry.
18.5.
Yeah, 9.25. Sorry. So moles of air, it will be 9.25 divided by 0.21, which will come out as 44.04. Okay. And the molecular mass is 6 into 12 plus 13, 85.
85.
Okay, so ratio will be 44.04 into 29 divided by 85 into 1. Calculate this. Is the answer matching now?
I got 14.2.
14.2
8.
by this calculation.
No.
Acha. So like can you check the options and tell like whether now it is matching or not? I guess I also have the assignment. Let me check. Please check. I'm not able to access it right now. Like if you are not getting this answer, then there would be some typing mistake in the question or in the options. You can follow the similar procedure if there is some changes in the question if it is given to you.
Yeah, okay.
Yeah, you can match the options and check. It would be better. Like procedure is what I have shown to you.
In calculation, can you open the calculation page, please?
Yeah, just a second, I will share. Anyway, I will share this PPT and the link will be provided to you, so you can go through the calculations what I have written. If you want, I can like if you are not able to find out properly, then I can just write the steps in a paper and I can paste a photo for you, if you want.
Yes,
That I
ma'am,
can.
please.
Okay, that I will do and upload the PPT. I guess you are able to access the PPT, right?
Yeah.
Yes,
Okay.
ma'am.
Okay. Any further doubt?
Thank you. Thank you very much.
No, no problem. Sorry. Yeah, if you do not have any doubt, then we can end this meeting for today.
Yeah, please, once open the calculation sheet.
Okay.
Uh, can you explain this, why we are getting 48.33 and why we have to calculate that point?
Yeah, sure. So, just a second. Okay, so that you know na, like if we want the combustion, then we will not be usually giving pure oxygen to the engine. Instead we will be using air in the engine, like that will be provided, and the oxygen which is present in the air, that will be used up for the combustion. I guess you understood that, right?
Yeah.
Yeah. So for the complete combustion of 1 mole of this fuel, we require this much moles of oxygen. Okay. Now based on this, we will know, like since the stoichiometry of like the fraction of oxygen in the air, you know, which is 21%. Okay. So based on that, if you calculate what is the amount of air you are feeding to the system or to the engine for complete combustion, so for that what you are doing, it is 10.25 divided by 0.21, because in 1 mole of air you will have 0.21 moles of O2. So if you have 10.25 moles of O2, then what will be the moles of air used? Okay. So
Okay.
by cross calculation you will find the moles of air which will be actually required. So and by finding out that, you will be able to calculate mass of air required to for complete combustion of 1 mole of fuel. I guess I have explained properly.
Yeah.
Okay. If Do you have any further doubt?
Nah, okay. Clear.
Okay. Anyone else has any doubt?
Hello, ma'am.
Yeah.
Where can we access these PPTs and the material that you're providing?
You will be given one link for that. The video of the recording of this video is also, like, I will upload on YouTube, and also I will share the PPT. The link will be shared to you. It
Is
will
it
get,
via mail or in
yeah,
mobile?
you will get on get the mail, I guess. I am receiving the mails every day from
It's
NPTEL.
there in the module page below the week.
It can be accessed through SOAM application also.
Yeah, it's there.
Okay.
Thank you.
Anyone else? So if not, let's end the meeting for today here. Thank you everyone. Thank you for
Yeah.
joining.
Thank you.
Yeah. Thank you,
Thank
ma'am.
you.
Thank you.